All right, we are now looking at 4B.2. I can calculate the probability of compound events. Do this because it's jumping around a lot. I can calculate the probability of compound events by identifying whether they are independent or dependent events. So we're looking at, again, two different types of events again. Two more types of events. So independent events is the first event, or I don't like that. I'm going to say the outcome of the first event does not affect, sleeves hitting the board, does not affect the outcome of the second event. And we use and here, and the probability of A and B equals the probability of A times the probability of B. Then we have dependent events, and it's just the opposite. The outcome of the first event does affect the outcomes and this one is a little bit different. And B equals, it's the probability of A, and you say times the probability of A given B. No, I did that wrong. Probability of B given A. So since it affects it, we instead of just multiplying by the probability of B, it's the probability of B given A has already happened. And so that's just a little bit different. We kind of just think of it when we have our different sample spaces. The other way to think about dependent events is the total has changed. Somehow. Okay? So usually it's in some way your total has changed. And we'll get lots of examples. Looking at number 1, I flip a coin and then roll a fair 6-sided die. So I was going to decide, are these independent or dependent? Well, if I flip a coin and then roll some other random die, whatever I get on that coin is not going to affect my die. My 6-sided die is still going to have 6 sides when I'm done. So this is independent. Okay. So the probability of A and B equals the probability of A of B, which is the probability of, I want to land on heads, times the probability of, one. Well, the probability of landing on heads is 1 out of 2. And the probability of rolling a 1 is 1 out of 6. 1 half times 1/6 is 1/12. Done. Okay. Number 2, I roll a fair 6-sided die twice. the first roll shows a 5 and the second roll shows a 6. Again, when I roll my first 6, I die the first time. When I roll it the second time, I still have the same 6 outcomes. My number of outcomes has not changed. So this is independent. Again. So the probability of a 5 and a 6 is probability of 5 times the probability of 6, which is 1 out of 6 times 1 out of 6, which is 1 out of 36. All right, looking at number 3. A bag has 6 black checkers and 4 red checkers. You take out a black checker, replace it, and then take out another black checker. Well, since I'm replacing it, when I go to do the second part of this, the number of checkers in the bag has not changed, right? So this is independent, and that replacement is a big part of it being independent. I haven't changed my total at all because I put the checker back. Okay? So this is the probability of black and black, which equals the probability of black times the probability of black. Okay. The probability of choosing a black checker, there's 6 black checkers. Since there's 4 red, there's 10 total. Choosing another black checker is 6 out of 10. And that equals 36 out of 100, and that does reduce to 9/25. Again, number 4, drawing a 1, 2, or 3 from 9 cards, numbered 1 through 9, replacing the card and drawing a 7, 8, or 9. Oop. I just meant to highlight replacing the card. So again, I am replacing it. My total number of cards in the bag has not changed. So this is another one that's independent. So the probability of 1, 2, or 3 and 7, 8, or 9 is well, I have 3 options out of 9 here. And I have 3 options out of 9. Sorry, that's supposed to be times. 3 options out of 9 here. That equals 9 out of 81, which equals 1/9. So we are done there. All right, let's go ahead and flip to the next page. So now, looking at number 5, right? A box contains a penny, a nickel, and a dime. Okay. My box contains 3 things. 1 penny, 1 nickel, 1 dime. I want to find the probability of choosing a dime first, and then without replacing it, choosing a dime. That's not right. Let's change that. That's going to be weird. Let's choose a nickel the second time. Without replacing it, choosing a nickel. So when I go to choose my dime, again, like we've already said, I have 3 coins in the bag. Or box. When I go to choose my nickel, I already chose the dime. The dime is gone. 2 points. Okay, so we're going to draw this out. I'm going to find the probability of choosing a dime first, right? I have a dime, a penny, and a nickel. So the probability of so this is dependent. I guess I should write that here. Right. Alright, my total has changed. Probability of dime. The probability of a nickel given, this line means given. We'll look more at that later. Dime. Okay, so the probability of a nickel given, I've already chosen a dime. The dime's the easy part. I have 1 dime out of 3 coins. When I go to choose the nickel, I have to remember I've already chosen the dime. Now that I've already done that, what's the probability of choosing a nickel? There's 1 nickel out of 2 coins. Right? So this is the probability of nickel given dime. The probability of just nickel would be 1 out of 3. Right? So you have to be careful with that. So my probability of a nickel, of a dime, then a nickel without replacing it is 1 out of 6. All right, let's look at number 6. The teacher of a class that contains 12 boys and 16 girls needs to pick 2 volunteers. Find the probability that she chooses a girl first, then a boy. I need 2 different volunteers. When I pick my first volunteer, everyone's still available. Now I have that first person, and I go to choose a second volunteer. I cannot choose that same person again. Therefore, my total number of outcomes is going to change, and therefore, this is dependent. So, at the beginning, we have 12 girls and 12 boys and 16 girls. I'm going to find the probability of girl, then boy. That's going to be the probability of a girl times the probability of a boy given girl. Again, probability of girl is easy. There's 16 out of 28, right? With 12 and 16, there's 28 total. Times. Now, the probability of a boy given. There's already been a girl chosen. I chose a girl. She is standing up the front of the room. There are now only 15 girls available. The probability of choosing a boy is 12 out of 27. If you're doing this type of probability on a non-calculated portion of the test, the easiest way to do multiplication is to reduce first. I'm going to show you why, right? Let's reduce 16 out of 28, which both of those are divisible by 4, which is 4 out of 7. Let's reduce 12 out of 27. It does reduce to 4 out of 27 divided by 3 is 9. Now I multiply 4 times 4 is 16. 7 times 9 is 63. You can still check at the end to see if anything reduces, okay, but that is our probability. All right, looking at number 7. A box contains 5 purple marbles, 3 green marbles, and 2 orange marbles. What is the probability of taking 2 purple marbles? Okay, and I'm going to have 2 purple marbles in my hand. When I take the first one, I'm not putting it back before I take the second one. So anytime I'm choosing 2 of something, it's going to be at like the same time. It's dependent. Okay, it says nothing about putting that the first purple marble back. I want to have 2 in my hand. So a box contains 5 purple. So I'm doing purple and purple, right? That's what this means. So the dependent is the probability of purple times the probability of purple given purple. I would not want to say this like 5 times fast. Lots of P's. Okay, the probability of purple. I haven't done anything yet. So I have 5 purple marbles out of 5 plus 3 plus 2 is 10. Now, for the probability of purple given purple. I've already chosen a purple marble. One of my purple marbles is in my hand. Now I have 4 purple marbles out of 9 marbles. Right? So I'm going to reduce, that's 1/2. Right? The other thing I see is if it's anywhere in the numerator and anywhere in the denominator, you can reduce when you're multiplying. So 4 and 2 can reduce. Right? Both of those can be divided by 2. And then 2 ninths. If you're struggling, use a calculator for now. But good to work. It is also good to work on our mental math every once in a while. All right, last question. There are 8 shirts in your closet, 4 blue, 4 green. You randomly select one to wear on Monday and then a different one on Tuesday. Don't want to be caught in the same shirt 2 days in a row. Not a good look. You guys wear uniforms every day. That's okay. So, what is the probability you wear both blue on both days, right? I am choosing a different shirt on Tuesday. That means I cannot choose that first shirt again. It's out of the options. My total options has changed. This is dependent. So, the probability of blue and blue. So, what's the probability of blue? What's the probability of blue given blue? Okay. Probability of blue. I have 4 blue, 4 green. Probability of blue is 4 out of 8, or 1/2. I think about that way. Now I have chosen a blue shirt. I now only have 3 blue shirts. So I go to choose my second blue shirt. It's 3 out of 7. This does reduce to 1/2, and we get 3 out of 14. All right, that is it. I will see you guys tomorrow. Have a wonderful rest of your day.